Every single second, thousands of packs of instant noodles are produced in factories around the world. A meal that cooks in just 3 minutes begins its life inside massive industrial machines powered by precision engineering and food science. From simple wheat flour to the perfectly shaped noodle block inside your packet, the journey is far more complex than most people imagine. Today, we are stepping inside an instant noodle factory to uncover the complete manufacturing process, from raw ingredients to final packaging. If you enjoy discovering how everyday foods are made on a massive scale, make sure to subscribe to Factory, Food, and Process. We bring you detailed factory documentaries every week. Now, let's begin at the foundation. Instant noodles start with surprisingly simple ingredients and a special alkaline solution known as kansui. Inside the factory, flour is stored in towering silos that hold thousands of kilograms. Automated systems measure exact quantities and release them into large industrial mixers. Precision is critical. Even small changes in water content or alkalinity can change the final texture of the noodles. Kansui plays a crucial role. This alkaline mineral solution strengthens gluten proteins in the dough, giving noodles their elasticity and slightly yellow color. Without it, noodles would be soft and fragile. With it, they become firm, springy, and resilient. Once measured, the ingredients enter massive horizontal mixers. Inside, rotating paddles combine flour and water under controlled conditions. As moisture spreads evenly, gluten proteins link together, forming an elastic network that gives noodles their chewiness. The mixing process must be carefully timed. Too much mixing can make the dough overly tough. Too little mixing, and it lacks structure. Sensors monitor humidity and temperature throughout. Within minutes, loose powder transforms into a dense, slightly crumbly dough. From there, the dough moves onto conveyor belts and enters a series of heavy steel rollers. At first, wide rollers compress it into a thick sheet. Then it passes through multiple rolling stages. Each set of rollers reduces thickness gradually. This step is essential because the final thickness determines cooking time and texture. Laser sensors continuously measure the sheet to ensure uniform consistency. By the final stage, the dough becomes a smooth, thin sheet ready for cutting. Next, the flattened sheet passes through rotary cutters that slice it into hundreds of thin strands. In seconds, one solid sheet becomes flowing lines of noodles. But they are still straight. To create the familiar curly shape, the strands move onto a specially designed conveyor system that gently compresses and relaxes them in rhythmic motion. The result is the signature wave pattern. This shape is not just for appearance. Curly noodles increase surface area, allowing hot water to penetrate faster during cooking. Engineering meets food science in every curve. If you are fascinated by how everyday foods are engineered at this scale, subscribe to Factory, Food, and Process. We explore the science and machinery behind the world's most consumed products. Now comes the transformation that makes them instant. The freshly cut noodles enter a high-temperature steam tunnel. Inside, intense steam surrounds the strands for several minutes. This partially cooks the noodles. Heat causes starch molecules inside the flour to gelatinize. They absorb water and swell, forming a stable internal structure. Steaming also locks in the wave pattern. At this stage, the noodles are cooked but still contain high moisture. To become shelf-stable and quick cooking, they must be dried rapidly. After steaming, the long strands are cut into specific lengths. Mechanical cutters divide them into uniform portions. Each portion drops into square or round molds, depending on packaging design. The molds compress the noodles into compact blocks. This shaping ensures consistent portion sizes and helps them fit neatly into packets or cups. Now comes the most critical stage. The molded noodle blocks are either flash-fried or air-dried. In the flash-frying method, the blocks are submerged in hot oil for a short time. At high temperatures, moisture inside the noodles evaporates rapidly. As steam escapes, it leaves behind tiny microscopic pores throughout the structure. These pores are the secret to instant cooking. When you pour boiling water onto the noodles later, water quickly fills these spaces, rehydrating them in just minutes. Some factories use hot air drying instead of frying. Powerful hot air circulates around the noodle blocks, removing moisture without oil. Both methods rely on precise temperature control. Too much drying makes noodles brittle. Too little reduces shelf life. After drying, the noodle blocks travel through cooling conveyors. Air circulation lowers their temperature gradually to prevent cracking. High-speed cameras inspect each block for damage or irregular shapes. Metal detectors and quality control systems ensure food safety standards are met. Only perfectly formed blocks continue forward. Meanwhile, flavor production takes place in another section of the factory. Large industrial blenders combine powdered spices, salt, flavor enhancers, and dehydrated vegetables. Flavor engineers carefully balance taste to maintain consistency in every batch. The seasoning mixture is then portioned into small sachets using automated filling machines. Each packet must contain an exact measured amount. Precision ensures every bowl tastes the same. In the final stage, the noodle block is placed into packaging. For packet noodles, the block and seasoning sachet are inserted into plastic wrappers. For cup noodles, they are placed directly into pre-formed cups. Some packaging lines inject nitrogen gas before sealing to remove oxygen and help preserve freshness. Heat sealing machines close each package instantly. Production lines can package thousands of units per hour. From raw flour to finished product, the entire process takes only a few hours. Yet these noodles may be stored and distributed globally for months. What begins as simple flour and water is transformed through engineering, chemistry, and precision machinery into one of the world's most convenient meals. From mixing and rolling to steaming, drying, and flavor packaging, instant noodles are a powerful example of modern food manufacturing efficiency. The next time you open a pack and pour in boiling water, you will understand the science behind those 3 short minutes. If you enjoyed this deep dive into how instant noodles are made, make sure to subscribe to Factory, Food, and Process for more detailed factory documentaries. And let us know in the comments which factory you would like us to explore next. Until next time, keep discovering how the world's favorite foods are made.